Hi, my name is Solomon, and today I will walk you through 4 different ways that you can work with your LoCoBot. The first way is to work directly on your LoCoBot. To do this, you have to attach an HDMI cable to the Intel NUC on the LoCoBot and to your monitor. You also need to attach a keyboard and mouse. By default, there are 4 external USB ports on the Intel NUC. So if you want to attach your keyboard and mouse to the NUC, you're going to have to remove 1 or 2 of them. Most likely, since you'll be working tethered with the LoCoBot, you're not going to be doing any type of navigation. So if you want, you could temporarily remove the USB going to the Kabuki base, as well as the USB going to your LiDAR if you have a LiDAR on your robot, in order to plug in the USB and to plug in the keyboard and mouse. So what are the pros of working directly on the LoCoBot? For one, there's minimal lag. So you're going to be, since you're working on the same computer as where all the processing is happening, there's going to be very minimal lag. There's no need to have another computer to work with the LoCoBot. And you can also monitor the LoCoBot in RViz directly. But there is one major con, and that is you're tethered to the LoCoBot. So if you want to do navigation or mapping, you can't really do that. The next 3 ways that you can work with the LoCoBot all involve networking. The first way is a minimal networking setup. The second way is more of a medium networking setup. And the third way is like a full-blown maximum network setup. So in the first scenario with minimal networking setup, what you're going to be doing is using an external remote computer to interface with a LoCoBot over a network. Specifically, you'll be using SSH. There is some setup required. First of all, you have to make sure that your computer, your remote or personal computer, has SSH capabilities, and that you can SSH into another platform from your computer. You also have to make sure that both the LoCoBot and your personal computer are connected to the same network. One way to do this is to get an external router and connect both your LoCoBot and your personal computer to the network created from the router. Another way to do it is to create a hotspot on the LoCoBot computer and just have your personal remote laptop or computer just connect to that hotspot. So some of the benefits for working over a network using this minimal setup is that, first of all, your LoCoBot can move freely around, so you can do navigation. Also, your personal computer only needs to support the ability to do SSH in a terminal. So any operating system, whether it's Windows, Mac, or Linux, that's capable of doing that can work. There are some cons, though. Since you are working over an SSH connection, there's no graphical user interface that you can use to monitor the LoCoBot, like in RViz. There's going to be a little bit more lag due to working over a network, and depending on how far away the LoCoBot is from your computer, or how good your router is, or how powerful the hotspot is, the lag could be more or less. Another con is that you're going to need your own personal computer to interface with the LoCoBot. And like I said earlier, there's a little bit of more initial setup required to make sure, like I said, that your computer and the LoCoBot are on the same network and that your personal computer has SSHing capabilities. So just to show you what that would be like for a minimal case setup, I'm working on a Ubuntu Linux 1804 laptop right now. There's no need to have any ROS installed. That's just the laptop I'm using. So I'm going with the hotspot approach. I've already created a hotspot on the LoCoBot called LoCoBot I-hotspot, but you can name yours whatever you want. So I'm just going to connect to that network. So you go to select network, LoCoBot I-hotspot, connect. And I've already pre-configured my hotspot on the LoCoBot so that you don't even need a password. Okay, so it looks like we're connected. I'm going to open up a terminal by pressing Control-Alt-T on the keyboard. And we're going to type SSH-X LoCoBot at LoCoBotI.local. So just a couple of things before we go in. The -X flag allows you to do window forwarding. So let's say I have some simple graphical user interfaces that I want to start on the LoCoBot computer. I can do that, and then the graphical user interface part will be forwarded to my personal remote computer. Like I said, you only want to do this with simple graphical user interfaces. The more complex they are, the more bandwidth and the more lag you're going to end up having or taking with by doing that. But in our case, the reason we're going to do this is so that we can open up a GNOME terminal instance on the LoCoBot. And when we get to that part, this will make a little bit more sense. Another thing to note is that I'm SSHing to LoCoBot at LoCoBotI.local. We have a bunch of LoCoBots in our office, and in order to differentiate between the LoCoBot I want to connect to and the other LoCoBots, I temporarily have changed the computer name of the LoCoBot I'm using to LoCoBotI. But in your case, all of your LoCoBot platforms will be called LoCoBot. So you should really be doing SSH-X LoCoBot at LoCoBot.local. Anyway, you press enter. You'll see this warning. Are you sure you want to continue connecting? Right, yes. Press enter. Password is by default LoCoBot, all lowercase. LoCoBot. All right, and I am in. So you can look at the different directories in your current working directory by pressing L and then typing enter. We have our Kakin workspace here for all of our ROS packages. Then we have like our AprilTag workspace and RealSense workspace. So everything is here that needs to be here. So we can, go straight and bring up the GNOME terminal GUI. So you can do that by typing GNOME terminal. You can even tab. It should auto-complete. And then the ampersand symbol. So what the ampersand symbol does is it'll run the process in the background and it won't leave the terminal hanging. All right, so this terminal GUI interface that we just opened, that's actually being run on the LoCoBot, and this little graphical interface part is being forwarded over the network to my screen. So the nice thing about this is, I can type a command like ROS launch Interbotix XS LoCoBot control XS LoCoBot python.launch robot model. In this case, I'm using a LoCoBot Widow X200, so I'm going to type LoCoBot WX200. And then I can press enter, and it should start that launch file. And then I can do Control-Shift-T on the keyboard, and it will open up another instance of the terminal on the LoCoBot computer. If I try to do that here, if I do Control-Shift-T in this terminal instance on the left, it's going to actually open up an instance on my current personal computer called Demo Comp. So that's something to keep in mind. One of the benefits of using this GNOME terminal GUI is that you can open up as many tabs as you want, all on the LoCoBot computer here on the right. So here what I'm going to do is just run a simple Python script. It'll just make the end effector of the arm follow like a square type of trajectory. So I'm going to ROS CD, which is a way to change directory into a certain ROS package. So I'm going to go into the XS LoCoBot control ROS package and change directory to the directory before that. Then go to examples, Python demos, and then I can type Python EE Cartesian trajectory and press enter. Oh, it looks like I have a little bug here. I have an extra R, so let's just fix that very quickly. Nano EE Cartesian trajectory.py. So Nano is a simple text editor that opens up in the terminal, allows you to make nice and quick fixes. So let's just fix this and then type Control O, enter, Control X, and Python EE Cartesian. Press enter again. All right. And this is happening off screen, but the arm is actually doing the motion it's supposed to be doing, which is good. That means our LoCoBot is working and we can successfully control the LoCoBot over an SSH network, which is what we were trying to do. Okay, so let's just shut that down, Control C. And we're going to exit from this terminal. All right. So that's the way to do it using a minimal setup. And I've already described the pros and cons of that. So let's go on to the next one. In the next case, you're working over a network in more of a medium setup type of thing. So the difference in this scenario is that you'll still be working on your own personal computer or laptop, and you'll also be working over SSH, but you will also have to configure ROS networking and run the remote software installation script. Before I do that, let's just list some of the pros and cons about this approach. So this has the same pros and cons as the minimal networking setup, but some differences are that in the medium setup case, I can actually open up RViz on my personal laptop and monitor the LoCoBot from my personal laptop in RViz, which is great when you want to like look at how the robot is mapping, or if you want to use the nav tool in RViz to give a certain goal pose to the LoCoBot when you're doing SLAM. So yeah, definitely pretty nice way to monitor stuff. You can also see what the camera is looking, what the camera is seeing, and what the LiDAR is seeing if you have that. Another nice thing is that RViz is pretty processor intensive. So by running it on your own computer instead of the LoCoBot computer, you're saving resources on the LoCoBot computer. Has the same cons as in the case of the minimal setup. A little bit of lag because you're working over a network, of course. In this case, the type of computer, your personal computer that you have does matter, since you will be running the remote software installation script. That does mean you're going to need to have ROS installed. So Ubuntu Linux and ROS is a must. And then you have to run the remote software installation script. This has a little bit more setup than the case of the minimal setup because you have to configure ROS networking. And also, in some cases, you may... Actually, never mind. You cannot run... Right now, you would have to run Python scripts directly on the LoCoBot. You couldn't run them on your personal computer. So that's another downside. All right, so let's install this remote software installation script. So first I have to go to my Wi-Fi network here. Let's select the network. We're going to go to TRNet. That's my office network. Okay. And here is the remote installation script. It's at github.com/Interbotix/Interbotix ROS rovers. And then you just click the Interbotix ROS XS LoCoBot tab, and it'll get you here. So just scroll down until you see the software setup, and we're going to go to the remote install setup. We're going to open up a terminal again, Control-Alt-T. And just so you can see for yourself, we don't have, oh, that's a lot of stuff. We don't have any, we don't have the Interbotix workspace here. It's not installed yet. So let's just follow these instructions. So sudo apt install curl. We already have it installed, so that's great. Let's just get the latest script. Paste. All right. And we actually already have a tutorial video that talks about how to install the remote software packages that you can look at I'm kind of just rushing through it here because, you know, we already have this video. All right, so just type chmod plus x, xs LoCoBot. Whoops, I downloaded the wrong one. We need this one, the remote install. The other one was the AMD 64 install, so we want to actually use this one. Okay. I'm just going to also do it on the previous one because we will need this in the next part of this tutorial. Okay, remote install, chmod plus x. By the way, that command, all it does is it makes it executable. So like you have permissions to execute the script. Otherwise, it won't run. And then we're going to type xs /xs LoCoBot remote install, and that's going to actually run the script. All right, so it's asking us what the host name of the robot computer is. Normally, you would just type LoCoBot like this. But in my case, since I've changed the computer name so that I can differentiate between my LoCoBot and others, I'm going to type LoCoBot I, then press enter. And it's just going to create the Interbotix workspace, clone the Interbotix ROS rovers repository, and any plugins we need for RViz to show the state of the LoCoBot. All right, cool. Just some warnings here. If you don't want to use the ROS packages in the Interbotix workspace, then all this is saying is you can go to your bashrc file and comment out this line from it, and also to comment out this line. All right, so talking about networking setup, let's go to the bashrc file. So one way of doing that is using nano, which is the one of the minimal text editors in Linux. So go type nano.bashrc, and then I'm just going to click the down arrow key to get all the way to the bottom. So what the installation script actually adds to this bashrc file is everything from this line all the way to the bottom. So this is that line here that sources the setup.bash file for the Interbotix workspace. This line here tells ROS where the ROS master is. And in our setup, the way this is going to work is the LoCoBot computer is going to be the master, and the personal computer is going to be, well, not the master. So you have to tell it where the master is located. So in this case, I'm telling it it's located at the LoCoBot I computer. So that's one of the main things you have to do to configure ROS networking is this line here. Also, what's important is to configure your ROS IP. So one way of doing that is just, it's already, this is already done for you on by the installation script. But if you were doing this manually, you would set this. You would also set your ROS IP to where your personal computer is located on the network. So all this line of code here does is it does it automatically. So like, sometimes depending on what network you're on, the IP will change. So this is just a little bit more robust. It's a way of saying, whatever the IP is, set it to the ROS IP environment variable. And then all this code here, what it does is it it checks to see if ROS IP has a valid IP address, and if there is a network, then it does. But if there's no network, if the computer isn't connected to any network, then it just doesn't have anything. In which case, it just sets it to the default. I think this is called the loopback address. And yeah, so this computer is done. We have the ROS master URI, we have the ROS IP, and on the LoCoBot computer, the ROS master URI points to itself, and the ROS IP there is set as well. So we are good to go. So Control X. And now let's try starting the LoCoBot ROS launch file, and we're gonna open up RViz here just to see that it works. So once again, we're gonna connect to the hotspot. I guess this is a weird bug in Ubuntu 18 that you have to click this twice to find all the available networks, but okay. So connect. Once we are connected, we're going to type ssh-x LoCoBot at LoCoBot i.local. Enter, yes, LoCoBot, and we are in. Let's do that GNOME terminal thing before, like we did before. Okay. And we are going to type ROS launch Interbotix xs LoCoBot control xs LoCoBot python dot launch robot model is equal to LoCoBot wx200. Enter. Okay, that's up. Now let's go to another terminal, and we're going to go to that same Python script that we ran before. So that's in ROS rovers, LoCoBots, samples, Python demos. All right, and before we run it, let's just get RViz up and running on our personal laptop here, which is called demo comp. So ROS launch Interbotix xs LoCoBot descriptions xs LoCoBot description dot launch, and I think let's just set the RViz frame to LoCoBot base footprint. Press enter. Looks like we have this error message here. Oh, right. So I'm actually launching the wrong file here. Hold on. So ROS launch Interbotix xs LoCoBot descriptions remote view.launch. That's the one you want to be running. And then RViz frame is equal to LoCoBot base footprint. Enter. Perfect. So right now, like the camera isn't on. All I have is just the bare minimum. But you can see the state of all the joints and that the camera is pointing down. All right, so when we run this Python script, we should see the arm in RViz move as well. So let's type python ee Cartesian trajectory.py and enter. And there we go. All it's doing is following a square trajectory. Like I said, this RViz is running on our personal laptop, not on the LoCoBot computer. Great. So that is what happens with the medium networking setup. All right, so let's Control-C out of that. Exit. Exit RViz. Close without saving. Exit here. All right. So let's move on to the next type of networking setup, and that is maximum setup. So this is when you work with your personal computer over a network, but in this case, you're doing the full software installation on your computer, along with having ROS networking as well. And this has all the benefits of the medium networking setup, but you would want to use the full maximum setup networking setup if you wanted to, for example, run Python scripts on your personal computer and have them control the robot. In the medium setup case, you would still have to run Python scripts on the LoCoBot computer, but in the full setup, you could run Python scripts even on your own remote personal computer, which is great because it will make any higher level processing that you want to do, not just with RViz, but for your Python scripts. So if you want to run some sort of neural network or do some sort of machine learning application, then you can have all of that run on a more powerful computer remotely and still talk with the LoCoBot computer over a network. And again, that also frees up resources on the NUC, so it doesn't have to do as much processing. And the cons are still the same. You need to have your personal laptop has to be running Linux and ROS a little bit, and also there's a little bit more setup required. Okay, so let's do that. Let's have that as a run through. All right, so let's go to network and go back to our Wi-Fi network, trnet. Okay. Since I've already installed the remote software stuff, I'm just going to delete all of this code that we just installed so that when I run the full installation procedure, it's as if I didn't have anything on the computer to begin with. So the way to do that is to type sudo rm-r Interbotix workspace like that. This will remove recursively all files in the Interbotix workspace. So press enter, type your password, and that gets rid of that. Another thing you can do is go to your bashrc file, and we're just going to get rid of the last few lines here, the lines that were added by the other installation script. So at this point, this is what the bashrc file looked like before I ran any installation script before. So type Control-O, enter, Control-X to save everything and exit out. And if you remember, we have already downloaded the installation script by accident from before. So to run it, we're just going to do /xs LoCoBot amd64 install.sh. Press enter. This will take a few minutes, so we'll just come back after all the LoCoBot software has been installed on my personal computer. All right, now that we have finished installing all the LoCoBot packages on our personal computer, let's go try running this on the LoCoBot while running a Python script from our personal computer. All right, so we're going to need to connect to the right network. So again, we're going to connect to LoCoBot I, hotspot, or you'll just connect to the router that your LoCoBot is connected to. If that's the way you went. SSH-x LoCoBot at locobot.i.local. Yes, LoCoBot, and we are in. So again, gnome terminal ampersand enter ROS launch Interbotix xs LoCoBot control xs LoCoBot Python dot launch robot model is equal to LoCoBot WX200 enter. All right, that's good. And now we're going to press Control-Shift-T on our personal computer. Let us start up RViz, ROS launch, Interbotix, xs LoCoBot, descriptions, remote view.launch. RViz frame is equal to LoCoBot base footprint. Oh, okay, so hold on a second. I have to actually set the ROS master URI variable here to point to the LoCoBot computer. So I'm just going to stick that right here. So export ROS master URI equals http //locobot i.local :11311, and we're going to Control-O, enter, Control-X, source the bashrc file to make those changes take effect, and we're going to run that script again. All right, we are back in business. Great. Now, having that on to the side, let's open up another terminal again on our personal computer here. Change directory into the LoCoBot control. Go to your Python demos examples, and we're going to run the EE Cartesian trajectory.py script here. Oh yeah, have to make that change again. have to fix that in a later update. Enter. I don't know what I did there. Okay. Enter. Control X. Python. Cartesian trajectory.py. And it's working. And that's how to work with Python scripts on your personal computer and have it command the robot on the robot computer. All right. Just shut down that. Shut down the launch file. And that pretty much covers the 4 different types of ways you can use the LoCoBot. Thank you for watching, and I'll see you next time.